Hello friends, today's question. A stationary source emits sound of frequency 492 Hz. The sound is reflected by a large car approaching the source with a speed of 2 meters per second. The reflected signal is received by the source and superposed with the original. What will be the beat frequency of the resulting signal in Hertz? Given that the speed of the sound in air is 330 meters per second and the car reflects the sound at the frequency it has received. So we are going to use in this question Doppler effect, and the Doppler effect will be used in two parts. In the first part, the sound will be received by the car, and in the second part, the sound will be reflected by the car. Let's start with the first part, and in this case, the sound is received by the car. You can say frequency of sound received by the car. And let us call that frequency as F car. And in this case, the car is a moving observer. We can say car is our moving observer, and source is stationary. So we can write the Doppler effect equation. That our F car will be equal to F naught and velocity of the sound Vs plus velocity of the car Vc divided by velocity of the sound. So here Vs is velocity of sound and Vc is the velocity of the car. We substitute the values, we get that our F car will be equal to 492, and this we have 330 plus 2 divided by 330, and this can be approximately as 495.03 Hertz. Next, we are going to find out the sound reflected by the car. So we say frequency of sound reflected by the car. Frequency of sound reflected by the car, and let us call that as F reflected, Fr. So in this case, the car reflects the sound it received, so it is going to act as now as a moving source. So now we have a source which is moving, and therefore we can write the equation that frequency reflected is equal to frequency of the car and velocity of the sound, and we get this velocity of the sound minus velocity of the car. So if you substitute the values, we get Fr is equal to 495.03. 330 is the velocity of the sound, and this is 330 minus 2, and this comes approximately as 498.03 0.03 hertz. And we are supposed to find out the beat frequency. So beat frequency is nothing but the difference between the two frequencies, the original and the reflected one. So we can say our beat frequency, if we call that as f beat, will be equal to f reflected minus f naught. We substitute the values. F reflected is our 498.03, and this we have 492, and this can be approximately written as 6 hertz. So this is our beat frequency. Yeah. So we can say this is the beat frequency. The beat frequency is 6 hertz. So this completes the question. Here it is FR, not FR minus. So this completes the question. Thank you.